Do you think it's difficult to keep one single cloud environment secure? What about securing multiple cloud environments across different cloud service providers? This course will give you an introduction to cloud security challenges and the motivations for security governance. We will talk about security architecture for multi-cloud and how to build it. A governance framework for cloud security will be introduced together with a lecture on policies and standards. Defining security standards in a real cloud environment will be discussed, and the course wraps up showing you an approach to security monitoring in the cloud. There are multiple templates available for download that supports the topics covered in this course. Just follow the links given in this video. Enterprises are increasingly pursuing the business advantages of migrating technology platform and services into cloud environments. Cloud customers are leveraging one or more of the three main cloud service areas: infrastructure as a service, platform as a service, and software as a service. Cloud computing advantages include, but are not limited to, rapid information system deployment, significantly reduced operating costs, and massive economies of scale, processing speed, and agility. However, subscription to these services often implies security and compliance challenges for enterprises who are often unprepared to resolve them. Data breaches, system vulnerabilities, insufficient identity and access management are some of the typical security challenges in the cloud that customers must address. In some situations, an enterprise may lack adequate operationalization and enforcement of policies and procedures, and even a properly constituted organizational function to effectively manage security in the cloud. In other situations, the enterprise may also not sufficiently exercise its responsibility to protect data in the cloud, or may lack the means of senior management visibility into cloud security performance and risk. These issues may prevail even when an enterprise stands to gain significant business benefits from transforming its service delivery model via the use of cloud computing platforms. The underlying business problem leading to these challenges is the lack of effective governance of cloud security. Multi-cloud strategies help enterprises avoid vendor lock-in, develop a robust failover design, and even optimize performance. However, while multi-cloud environments can efficiently support the business, there are potential security pitfalls, and they often arise when a company adopts multiple cloud solutions without a clear identity and security strategy in place. Without a centralized view of cloud access and activity across each cloud environment, things get complicated quickly, and IT teams are left to face the security and compliance challenges. They are likely to miss risky behaviors and other risk signals, such as overall risk exposure and access leaks. Workloads go through many life cycles, from staging to deployment to backup, and eventually have to be securely decommissioned. Each stage poses different risks of potential data theft or other misuse. Managing workload encryption from each cloud management's platform is complex, and further increases the risks of inconsistent policies and mistakes. Additionally, an encryption strategy that aligns with compliance mandates requires robust key management. Unfortunately, key management is not universal across cloud platforms, so the security team must contend with key storage, distribution, rotation, and revocation in multiple environments. What's more, when encryption keys are not completely separated from the workloads and the data they protect, the potential exists for a security incident that compromises both, leaving data exposed to a breach. Best practices call for the use of certified hardware security modules to protect your encryption keys. Encrypting cloud data is essential to protecting sensitive information and workloads, but it needs to be done correctly in order to be effective and meet compliance mandates. Some important recommendations related to cloud data encryptions are as follows. Use hardware security modules to store encryption keys separately from cloud workloads. Use a centralized hardware security module infrastructure to manage the encryption keys used across cloud environments. and rotate your keys regularly to ensure alignment with compliance requirements and auditor expectations. These security measures are critical to protecting your cloud data and workloads, and it's vital to get them right from the outset. While multi-cloud strategies have their clear strength, security and governance vulnerabilities can arise along the way, particularly because each provider has its own take on identity, privilege, and entitlements management. This complicates security and compliance for identity and security teams, and if not addressed, can leave companies vulnerable to breaches, attacks, and other security events. The pressure for fast access as IT and operations teams try to adapt often results in user being over-provisioned, separations of duties violations within applications as they were rapidly transitioned to the cloud, and finally fragmented identity strategies with silo identity stores being created within cloud platforms to get things working rapidly. The biggest challenge is sheer complexity. Because each cloud is different, many organizations that have embraced cloud technology still have separate teams managing each public cloud. They have an Azure team, a Google Cloud team, and one that manages AWS. So there's often a lack of visibility and collaboration across teams, especially when provisioning and deprovisioning access to resources as users move throughout the identity management lifecycle. You've got development teams, you've got application teams, IT teams, infrastructure teams, etc. All this complexity leaves the door open for cyber attackers because there's no centralized view. This is why the need for greater visibility across clouds is so critical. When securing multi-cloud infrastructures, each cloud provider has its own model for how identities and privileges are managed. Those models have different roles and different security controls, creating the need for solutions that can manage identity across clouds. It can be difficult for enterprise application development or IT operation professionals to get their arms around multi-cloud DevOps. That's because a single multi-cloud deployment might depend on hundreds of remote application and infrastructure components. These in turn might use a myriad of interfaces and orchestrations and execute in dozens of clouds with varying degrees of federated interoperability. To ensure the continuous integration and continuous delivery, the so-called CI/CD, of applications and infrastructure across increasingly heterogeneous clouds, enterprises will need DevOps tools that integrate with those platforms. The tool should allow for flexible movement, monitoring, scaling, and transparency, and the management of infrastructure and application components, data, workflows, metadata, and business logic. Managing complex multi-cloud environments requires full-spectrum DevOps to drive CI/CD across both public and private clouds. Enterprise application development and operations professionals who wish to implement continuously automated software development, testing, and release pipelines across their multi-clouds should consider the following. Assess the extent to which your enterprise requires end-to-end DevOps that spans two or more public or private clouds. Identify the extent to which your enterprise existing infrastructure as a code and other DevOps tools support CI/CD workflows for infrastructure and application components, such as code builds and machine images across your hybrid multi-clouds. Evaluate the growing range of commercial DevOps tools to determine whether they integrate into your various clouds' native DevOps tools. Also evaluate whether these can build automated CI/CD workflows that span clouds seamlessly and can manage the deepening stack of code and machine images and other assets at the heart of your multi-cloud application environment. So why do we need cloud security governance? Cloud security governance enables organizations to reach new levels of agility, efficiency, and cost savings while operating within the cloud. It helps reduce proliferation of shadow IT, helps ensure privacy of resources, facilitates data compliance, and prevents budget overruns. Cloud security governance helps organizations implement frameworks that allow for easy access to cloud resources. In spite of zero trust, compliance, budgetary, or technological constraints, In other words, cloud security governance makes life easier. Do we really need a governance strategy for the cloud? Building a governance strategy can seem a bit overwhelming, but breaking down the process into a few key steps can help a lot. Before starting out, understand what's in your organization's cloud. Take the time to inventory the assets that have already been deployed in the cloud, learn about how they interoperate, and note potential security concerns. Optimize for cost and performance. Ensure that the cloud strategy aligns with the broader business and IT strategies. On this account, you may choose to swap out one cloud provider's services for those of a vendor whose structure better fits in your operational needs. You may also opt for another vendor to take advantage of discounted pricing offers. Develop processes and practices. Clarify how different departments intend to use cloud-based resources and understand their access requirements. Collaborate with the appropriate stakeholders across your enterprise to create optimal rules for cloud governance. Keep the need for flexibility and the prospect of possible revisions to policies in mind as you move forward. Consider cloud governance automation software. This technology can execute predetermined procedures in the event of a rule violation. Cloud governance automation software can also request approval for an event beyond the parameters of set governance rules or automatically remove an asset. In short, cloud governance automation software can remove a large portion of the manual work involved in cloud governance. Building a cloud security governance model for an enterprise requires strategic-level security management competencies in combination with the use of appropriate security standards and frameworks. The first step is to visualize the overall governance structure, inherent components, and to direct its effective design and implementation. The use of appropriate security standards and frameworks allow for a minimum standard of security controls to be implemented in the cloud, while also meeting customer and regulatory compliance obligation where applicable. A governance framework provides referential guidance and best practices for establishing the governance model for security in the cloud. The following key objectives are important to pursue in establishing a governance model for security in the cloud. The first objective is strategic alignment. Enterprises should mandate that security investments, services, and projects in the cloud are executed to achieve established business goals. For example, market competitiveness, financial or operational performance. The second objective is value delivery. Enterprises should define, operationalize, and maintain an appropriate security organization with appropriate strategic and tactical representation. This organization will have the responsibility to maximize the business value from the pursuit of security initiatives in the cloud. As I mentioned in the previous lecture, this is often called the Cloud Center of Excellence. The third objective is risk mitigation. Security initiatives in the cloud should be subject to measurements that gauge effectiveness in mitigating risks to the enterprise, the so-called key risk indicators. These initiatives should also yield results that progressively demonstrate a reduction in these risks over time. The fourth key objective is effective use of resources. It is important for enterprises to establish a practical operating model for managing and performing security operations in the cloud. This includes the proper definition and operationalization of due processes, the institution of appropriate roles and responsibilities, and use of relevant tools for overall efficiency and effectiveness. The fifth key objective is sustained performance. Security initiatives in the cloud should be measurable in terms of performance, value, and risk to the enterprise. The security initiatives should yield results that demonstrate attainment of desired targets over time, the key goal indicators. Build a holistic security governance program for the cloud. Use the knowledge, templates, and methodology presented in this course to build your own holistic governance program. You need to build a cross-functional team of experts that can handle management, architecture, and operations using a risk-based approach. The team must also consist of employees responsible for risk and compliance. Their task is to evaluate cloud providers' security capabilities, privacy agreements, and overall risk profile. Plenty of organizations adopt a multi-cloud architecture as a result of prudent planning and strategic decision-making. In other words, they end up there by design. Many other businesses arrive at the destination by accident. Different teams within an organization will make their own decisions about cloud services, or an acquisition will bring together people and technologies that never expected to be joined. There is only one best approach to application deployment and security, and that is to make all hosting resources look and behave the same. Any variations in how you operationalize your deployment and maintenance of application will complicate the security procedures you adopt. This is because the implementation and even the capabilities will differ across your hosting options. That's true for the hybrid cloud and is especially true for multi-cloud environment. Each cloud provider and your own data center has independent hosting frameworks that you'll need to secure. Plus, the workflow that pass among the providers and into your virtual private network are part of the security challenge. Multi-cloud security technologies must address four kinds of security challenges. First, they have to provide access security for the applications and components hosted in any public cloud, no matter which cloud is used, and no matter how many applications are moved or spread among public cloud providers. Second, security tools need to provide information security for company data hosted in or connected with each multi-cloud provider. Third, both of the mentioned challenges must be addressed during redeployment of components when a failure occurs or when components are scaling under load. And finally, security technologies need to accommodate new service providers or features as they're added. When going into details for security architecture principles for multi-cloud, we recognize that these are quite similar to security architecture principles in general. We start with layer defense. As in medieval times, when a castle had multiple walls of defense, similarly, we want to layer our defenses that protect our assets in the cloud. Separation of privilege. This security principle states that whenever a user tries to gain access to a system, the access should not be granted based on a single attribute or condition. Instead, there must be multiple situations or conditions or attributes which should be verified to grant access to the system. We also term this as a multi-factor user authentication, as this principle says that multiple techniques must be implemented to authenticate the user. We have also least privilege. The least privilege security design principle states that each user should be able to access the system with the least privilege. Only those limited privileges should be assigned to the user which are essential to perform the desired task. An example of considering and implementing this principle is role-based access control. The role-based designed security mechanism should discover and describe various roles of the users or processes. Now, the least set of privileges should be assigned to each role which is essential to perform its functions. So, the access control mechanism enables each role only those privileges for which is authorized. The least set of privileges assigned to each role describes the resources available each role can access. In this way, unauthentic roles are enabled to access the protected resources, like the users accessing a database has privileged only to retrieve the data. They are not authorized to modify the data. Isolation. This security design principle is considered in three circumstances. The first condition, the system has critical data, processes, or resources must be isolated such that it restricts public access. It can be done in two ways. The system with critical resources can be isolated using both physical and logical isolation. The physical isolation is one where the system with critical information is isolated from the system with public access information. In logical isolation, the security services layer are established between the public system and the critical systems. The second isolation condition is that the files or data of one user must be kept isolated with the files and data of another user. Nowadays, the new operating system has this functionality. Each user operating the system have an isolated memory space, process space, file space, along with the mechanism to prevent unwanted access. And the third isolation condition is where the security mechanism must be isolated from such that they are prevented from unwanted access. Zero Trust is designed to protect modern digital environments by leveraging network segmentation, preventing lateral movement, providing level 7 threat prevention, and simplifying granular user access control. Zero Trust was created by John Kindervåg during his tenure as Vice President and Principal Analyst for Forrester Research, based on the realization that traditional security models operate on the outdated assumption that everything inside an organization's network should be trusted. Under this broken trust model, it's assumed that a user's identity is not compromised, and that all users act responsibly and can be trusted. The Zero Trust model recognizes that trust is a vulnerability. Once on the network, users, including threat actors and malicious insiders, are free to move laterally and access or exfiltrate whatever data they are not limited to. Remember, the point of infiltrations of an attack is often not the target location. Zero Trust speaks for itself. Organizations that comply with Zero Trust do not trust anything within their networks and platforms. Every device, applications, or user is monitored. Platforms are microsegmented to avoid devices, applications, and users from being anywhere on the platform or inside the network. They are strictly contained. The pitfall here is to think that Zero Trust is about technological measures only. It's not. Zero Trust is foremost a business principle and looks at security from a different angle. Zero Trust assumes that an organization has been attacked, with the only question left being what the exact damage was. Security by design means that every component in the environment is designed to be secure from the architecture of that component, built-in security. This means that platforms and systems, including network devices, are hardened and that programming code is protected against breaches via encryption or hashing. This also means that the architecture itself is already microsegmented and that security frameworks have been applied. An example of a commonly used framework is the Center of Internet Security, CIS. CIS contains 20 critical security controls that cover various sorts of attacks on different layers in the IT stack. As CIS themselves rightfully state, it's not a one-size-fits-all. All organizations need to analyze what controls should be implemented and to what extent. Secure by design is increasingly becoming the mainstream development approach to ensure security and privacy of software systems. In this approach, security is built into the system from the ground up and starts with a robust architecture design. Holistic data protection is a principle for keeping your valuable data secure. An example of this principle is that the architecture must comply with the General Data Protection Regulation, the GDPR. This amounts to a lot of work when it comes to securing and protecting environments where data is stored and how data is accessed. Technical measures that will result from this principle will vary from securing databases, encrypting data, and controlling access to that data with authentication and authorization. In multi-cloud, this can be even more challenging than it already was in the traditional data center. Using different clouds and platform as a service and software as a service solutions, your data can be placed anywhere in terms of storage and data usage. Designed for cloud native. Cloud native apps are defined with roles and functions and build on the principles of code-based modularity and the use of microservices. These apps communicate with other apps using APIs or even triggers that call specific functions in other apps. These apps don't even have to run in the same platform. They can be hosted anywhere across different cloud service providers. Using cloud-native controls for security will also give you numerous benefits in terms of cost and the level of control. However, it may be difficult to rely on controls from one cloud service provider to cover multi-cloud deployments. Additional tools may be needed for a broader visibility of security information across cloud service providers. Centralization and automation. With a multi-cloud system, operations and security teams potentially face a fragmented set of security access controls and monitoring tools. This presents a challenge if they're designed and implemented uniquely in each separate provider environment. Some cloud operation teams look to multi-cloud brokers to centralize and integrate all cloud management into one place. Others select a single product or platform that can integrate into all the necessary provider environments, enabling central control of security policy and access management regardless of the underlying cloud infrastructure. Look for vendors that can offer cross-platform capabilities. Ideally, if you have a selection between vendors that are most equal in capability and cost, prioritize the one that has better coverage across multiple cloud environments. This is also the case for forensics and response tools that are in use by incident response, forensics, and SOC teams. They will need to streamline their processes and playbooks as much as possible to use a unified evidence collections and investigation strategy. In this lecture, I will talk about the steps that will be necessary for you to go through when designing and building a cloud security architecture. This approach can be used both for an organization-wide scope and for projects. I will explain the use of methodologies, frameworks, and standards, and how to use this in your own process. I will introduce risk management and describe the most prevalent risks in cloud deployments. Implementation strategy is important also for cloud, and I will talk about what choice and priorities that can be made when developing a strategy. Finally, I will talk about compliance in the cloud and how to document your cloud architecture. There are multiple methodologies and frameworks to choose from. Even though they are not created for use with cloud architectures, they can be adapted and used to design and build solid cloud architectures. The methodology should follow a top-down approach, starting with gathering of business and regulatory requirements. Risk management is an essential part of a security architecture, and identified risks and their mitigation strategies should form the basis for your cloud security approach. A sound strategy is vital. Maybe your organization already has established a cloud strategy. The strategy should cover how applications are migrated to the cloud or built as native cloud applications. This will also have an effect on how to secure those applications and the infrastructure they are deployed to. Always document the design and implementation of security architecture in the cloud. Ensure that you can trace the rationale of deploying a security control back to its business or regulatory requirement, and vice versa. Implement the controls using infrastructure as code. This will help you streamline and automate deployments and reduce the risk of manual configuration errors. I'm going to talk a little bit about framework, standards, and methodology that we can use in our architecture work. SABSA is a popular methodology for developing business-driven, risk and opportunity-focused security architectures at the enterprise level. It can be adapted for use in projects, but also for use with cloud architecture. SABSA ensures that the needs of your enterprise are met completely and that security services are designed, delivered, and supported as an integral part of your business and IT management infrastructure. Although copyright protected, SABSA is an open-use methodology, not a commercial product. SABSA does not replace ITIL, ISO 27001 or NIST frameworks, but rather enables their deployment and effective integration into the corporate culture. NIST has a comprehensive security framework consisting of 3 components: core, implementation tiers, and profiles. The NIST framework core provides a set of desired cybersecurity activities and outcomes using common language that's easy to understand. The core guides the organization in managing and reducing the cybersecurity risks in a way that complements an organization's existing security and risk management processes. The NIST framework implementation tiers assist organizations by providing context on how an organization views cybersecurity risk management. Chairs are often used as a communication tool to discuss risk appetite, mission priority, and budget. NIST framework profiles are an organization's unique alignment of their organizational requirements and objectives, risk appetite, and resources against the desired outcomes of the framework core. Profiles are primarily used to identify and prioritize opportunities for improving cybersecurity in an organization. ISO 27001 is a widely known cybersecurity standard providing requirements for an information security management system. There are more than a dozen standards in the ISO 27000 family. Using them enables organizations of any kind to manage the security of assets such as financial information, intellectual property, employee details, or health information. Many cloud service providers offer security controls mapped to the ISO 27001 standard. The CSA Cloud Controls Matrix, the CCM, is a cybersecurity control framework for cloud computing, composed of 197 control objectives that are structured in 17 domains. The CCM can be used as a tool for systematic assessment of a cloud implementation. It provides guidance on which security controls should be implemented by which actor within the cloud supply chain. The KAIK, as I talked about earlier in the course, is a questionnaire answered by the cloud provider. It matches the structure of the CCM. The controls in the CCM are mapped against industry-accepted security standards, regulations, and control frameworks, including ISO 27001 and NIST. Frameworks can be combined and used together in a structured way. It's important that you tailor the methodology to your own organization. Use and incorporate the frameworks you consider most appropriate for your business needs. Risk management is a very wide topic that deserves its own course. In this course, I will talk about managing risks that are important to cloud architectures. Risk management is an important part of developing a security architecture. You need to be aware of the risks that you face as a cloud customer and how to mitigate them. You should conduct a risk analysis during your security architecture development project. Guidance on how to perform a risk analysis is not part of this course, but good documentation can both be found in the SAPSA methodology and in the NIST CSF. Choose a methodology in the framework that suits you the best. The first and most important part of the analysis is to identify the risks. I have given references to information on cloud risk in this slide. Both CSA and ENISA offer good descriptions of cloud risks. This is a very good starting point. You should, depending on your architectural requirements, come up with more detailed risks covering the specifics of your services or solutions. Once the risks are identified, they must be scored and prioritized. The security services and controls in your architecture should be implemented to mitigate the risks that you have identified. If your business has a low risk appetite, then ensure that you use a defense-in-depth model where security controls are incorporated at each layer. Many organizations develop a cloud strategy. A strategy will help the organization get the most benefits from the cloud initiatives. The strategy takes all the aspects of cloud mentioned earlier in this course into account. The choice of service and deployment model will impact the way cloud services are implemented and secured. A strategy covers data classification, change management, and operational aspects. An important consideration in the cloud that should be included in the strategy is the use of services. One way to go is to choose SaaS and PaaS over IaaS as a service model. Then you buy operational services from the cloud provider, and according to the shared responsibility model, more responsibility for security is shifted to the cloud provider. Similarly, you can buy security controls from the cloud provider as a service. This is often called security as a service. Change management is important for cloud consumers. The services you buy from the cloud provider will be updated throughout the usage period. Update notifications will be sent to you as a customer, and you need a way to handle the changes in case they affect the way you and your organizations use the cloud services. Additionally, you have to handle your own changes, both to configuration and to code deployed to the cloud. You should handle changes in the cloud the same way you handle changes in your own data center. iTool could give you a good set of service management practices. Cloud operation is all about centralization, standardization, and automation. This also applies to security operations. Monitoring of security events can be centralized, handling of the events can be automated, and deploying new environments can be standardized and also automated. You can do more in the cloud with fewer personnel resources. Your cloud implementation strategy should not be a document ending up in your project archive, but rather be a living document that you constantly seek to improve. The major cloud providers offer a lot of documentation on their compliance status. Independent auditors perform assessments of the cloud vendor's infrastructure, operations, and procedures. Their audit reports are available to cloud customers as documents downloadable from the cloud vendor's portal. The cloud service provider should demonstrate compliance with industry standards and frameworks such as ISO 27001 and CSA Cloud Controls Matrix. If you plan to host regulated data, you must ensure that your cloud provider meets compliance requirements such as PCI DSS, GDPR, and HIPAA. When you, as a cloud customer, deploy your solutions and services on top of the already compliant cloud infrastructure and services, it will be your own responsibility to stay compliant with the same standards and regulations. That means, for example, that your solution must be compliant with GDPR if your user base is located within the EU. You should gain knowledge about regulations, frameworks, and standards such as GDPR, ISO 27001, PCI DSS, and HIPAA, depending on your business requirements. Follow the links in the resources folder in this section to learn more about regulations, frameworks, and standards. So why do we need architecture documentation? We need to document our architecture work to use this for communications with different stakeholders. If you have chosen a methodology and framework, these will help you to structure your documentation. In my work, I often use drawings to visualize the architecture. This is very effective with most stakeholders, from C-level executives to developers and infrastructure specialists. But remember that you need a different level of abstractions for use with different groups of stakeholders. As I talked about earlier in this course, traceability is important for most stakeholders. You want to be able to prove why a security control is needed and trace it back to a regulatory or business requirement. Management or legal team members often ask how a certain requirement is covered. Then you need traceability from the top down to a specific security control. My advice is to use visualizations and explanatory text. Keep documentation short and concise, and map to standards and regulations. Always keep it updated. An information security governance framework for cloud computing is a set of policies, procedures, and standards that organizations put in place to protect their data and systems when using cloud services. The goal of such a framework is to ensure that the organization's information assets are protected against unauthorized access, use, disclosure, disruption, modification, or destructions, while also ensuring compliance with regulatory requirements. A comprehensive information security governance framework for cloud computing should include many different components. A governance structure establishes the roles and responsibilities of the various parties involved in managing the information security in the cloud, including the board of directors, the chief information security officer, the CISO, and other senior executives. Risk management outlines the process for identifying, assessing, and mitigating risks associated with using cloud services. This may include conducting regular security assessment and penetration testing, as well as implementing security controls such as encryption and multi-factor authentication. Compliance ensures that the organization's cloud computing activities comply with relevant laws and regulations, such as the General Data Protection Regulation, the GDPR, and the Health Insurance Portability and Accountability Act, HIPAA. Incident management outlines the process for responding to security incidents, including incident response planning, incident detection and investigation, and incident response and recovery. Security controls defines the specific technical and organizational measures that must be in place to protect the organization's data and systems in the cloud, including access control, network security, and data encryption. Vendor management outlines the process for assessing and managing the security of third-party cloud providers and the data stored with them. This may include conducting regular security audits of cloud service providers and implementing service-level agreements that include specific security requirements. Education and awareness ensures that employees are aware of risks associated with using cloud services and are provided with the training and resources needed to use cloud services safely and securely. Monitoring and reporting provides ongoing oversight of the organization's cloud computing environment, including regular monitoring of security-related events and reporting of security-related incidents to senior management. It's important to note that any governance framework for cloud security should be flexible, scalable, and adaptable to changes in the environment in order to continuously improve the overall security posture of the organization. Simply adopting an off-the-shelf approach is not enough. A security framework is only a framework. You must develop your detailed policies, standards, architecture solutions, and governance to implement the framework in a way that meets your needs and fits your circumstances. This is the difference between security frameworks such as NIST 800, NIST Cybersecurity Framework, or ISO 27001, and your internal security artifacts. International public standards require individual policies and corresponding standard because they help organizations manage their particular security programs effectively. Material created internally can leverage security frameworks for structure and ideas, but it is specific to the organization. Public security frameworks invariably contain guidance on implementation and customization of your own security framework as a best fit for your organization. The Cloud SARC methodology, introduced in a previous section of this course, will form the foundation of a simple and practical approach to cloud security governance. The input to the cloud security governance process are the outputs from previous stages in the methodology. We leverage the security and compliance specification, the cloud security strategy, and the risk assessment as inputs to the cloud security governance process. The Cloud SARC governance framework will be implemented using the operational stages of the Cloud SARC methodology. The Cloud SARC governance framework implements three main processes. Direct, where security governance can establish policies and define a pack of metrics to be measured in an interactive and step-by-step way. Monitor, where measurements are gathered during the processes are enacted. Monitoring requires to include pieces of software at the processes that enable to collect information about the metrics. Evaluate enables the security governance to analyze the different metrics in order to decide whether new countermeasures should be applied. This process can be carried out manually when governance needs, or a report can be obtained regularly. In the Cloud SARC governance framework, direct and evaluate is performed by cloud security governance. The direct process is responsible for setting the direction for the organization's IT governance and management activities. This includes setting goals and objectives for the organization's IT governance and management processes, as well as developing and implementing policies, standards, and procedures to support those goals and objectives. The direct process also includes the management of the IT governance and management processes themselves, such as the allocation of resources, the assignment of responsibilities, and the coordination of activities. The evaluate process is responsible for assessing the effectiveness of the organization's IT governance and management processes. This includes evaluating the organization's IT strategy, policies, standards, and procedures to ensure they are aligned with the organization's overall business objectives. The evaluation process also includes assessing the effectiveness of the organization's IT risk management and compliance activities. The monitor process is performed by cloud security operations in the cloud site governance framework. The monitor process is responsible for monitoring the effectiveness of the organization's IT governance and management activities. This includes monitoring the performance of the IT governance and management processes, as well as monitoring the compliance of the organization with relevant laws and regulations. The monitoring process also includes the collection and analysis of data to support the evaluation and direction activities. The direct monitor and evaluate processes are designed to be a continuous cycle, with each process feeding into the next. The evaluation process provides input to the direction process, which in turn provides input to the monitoring process. The monitoring process provides feedback to the evaluation and direction processes, which are then used to continuously improve the effectiveness of the organization's IT governance and management activities. Cloud security governance and cloud security operations are functions within your company, taking care of the processes direct, monitor, and evaluate. Follow the link in this section to download the Cloud Security Governance Framework document. In this document, you will find a description of the tasks for each of the processes direct, monitor, and evaluate. The Cloud Security Governance Framework also gives information about roles and responsibilities for the different tasks. Among the outputs from these processes are updated policies, standards, and procedures for information security. As mentioned earlier in this section, policies are implemented in the cloud service provider's environment using the relevant standards. Cloud security operations use the procedures when administering an updated cloud environment and the applications hosted there. The policies implemented in the cloud environment are part of the cloud security posture. The cloud security posture is the cloud security controls in the cloud environment, selected and configured to fulfill the policies and cloud security requirements from the security and compliance specification. I will talk more about the cloud security posture in the last section of this course. Download the Cloud Security Governance Framework document. You should customize this document to fit your own requirements and needs. The document is a template based on the processes described in this lecture. Adapt the tasks under each process to become relevant for your company and its business objectives. Policies and standards are elementary governance mechanisms. Well-written policies and standards have a clear traceability back to the very top of the strategy and help the reader to understand why the policies are needed. Every organization must have at least a basic set of formal policies and corresponding standards that is contextualized to its unique business. Without such a baseline, there is no way of verifying compliance. In addition to their obvious usefulness, security policies and standards introduce several challenges. I know from experience that writing good policies can be a difficult task. They must be structured and written so that they are accessible to people who need to use them. They must clearly tell people what needs to be done and who needs to do it, avoiding ambiguity and doubt. They have to balance security and business goals to leave enough room for agility and innovation. It's important that they are compiled in such a way that compliance with them can be monitored and enforced. They must be developed in such a way that they are harmonized and support security architecture approach that ensures that requirements are aligned and coherent. The policies should be introduced to address a need for risk management, consistency and standardization, and compliance. It starts with directives, in which senior management gives the security organization a mandate to develop and enforce policies based on high-level principles or based on a determined approval process. The security directives provides the foundations for effective information security governance across the enterprise and the mandate for an information security organizational function. It communicates executive commitment to security risk management and is the cornerstone of the security policy framework. Policies will cover the control objectives, requirements, and expectations that an organization has to secure business assets. Policies refer to governance that is strategic and outlines the direction the organization wishes to take for particular topics. A security policy defines and documents an organization's statement of intent, principles, and approach. It will adapt to ensure effective management of cybersecurity risks in pursuit of its strategic objectives. Standards will describe how those objectives will be implemented into the infrastructure of the organization. Standards contain a level of detail closely related to architecture that is not directly relevant to many individuals in the organization. The prime audience usually consists of technical professionals tasked in developing solutions that meet the organization's risk management objectives. Security standards set the minimum requirements for protecting an asset within a context or scenario. They prescribe the use of technologies, architectures, specific tools, designs, services, or processes to meet the scenario risk. Procedure documents mandate that something must be implemented in a specific, even step-by-step way. These mandatory documents specify how the requirements in the standard must be achieved. For example, a server standard may require that a specific approach to hardening is taken. The configuration for hardening would be documented in a specific server hardening procedure, including scripts for server hardening profiles. These documents are written by technical domain experts rather than security personnel as part of a security policy framework process. They are subject to relatively frequent changes, both as technology use changes within the organization and as vendors develop their systems. The procedure documents include detailed steps and configuration items that may be subject to scripting, imaging, and automated ongoing checks for compliance. Procedure documents often use public or vendor baselines, possibly without change. An example of this is the CIS benchmarks. Guidelines are discretionary. If there is a need, they will describe how to implement behavior policies. They also used to make third parties aware of detailed implementation or handling requirements, or to outline intricate dependencies. Typically, guidelines make everyone aware of their day-to-day responsibilities to protect data, the company, clients, and colleagues in a simple language. Give everyone an understanding of how the organization views data confidentiality and how they should judge the sensitivity of any piece of information. Guidelines will also inform everyone of the basic processes they should follow given a specific circumstance, such as requiring access to a system or application. While your policies will outline the high-level requirements, the corresponding standards will add the details. There might be a one-to-many relationships between policies and standards, as the standards for different platforms will be specific. Also considering adding compliance measurements requirements to the artifacts. Start with measurement objectives on the policy level and describe how those objectives are implemented to different platforms as metrics in the standard. So, when implementing the policies in the environment that you have created, using your chosen cloud service provider standards, you should be able to monitor and measure how well the implementation fulfills the intentions of the policies. In section 4 of this course, we will take a look at how to implement policies in the cloud using cloud-native tools. These policies are more specific than the high-level governance policies that we have covered in this lecture, and they can be technically enforced in the multi-cloud environment. In today's rapidly evolving technological landscape, the adoption of multi-cloud strategies has become increasingly prevalent among organizations seeking flexibility, redundancy, and the freedom to choose the best services from various cloud providers. However, with this decentralized approach to data storage and processing comes the challenge of maintaining consistent and robust security postures across different platforms. Security policies in multi-cloud environments therefore play a vital role in ensuring that data remains safe, compliance is achieved, and operational efficiency is maintained. These policies act as a set of guidelines and rules that govern the access, storage, and transfer of data across the separate cloud platforms. Creating an effective multi-cloud security policy requires a deep understanding of the unique features, strengths, and potential vulnerabilities of each cloud service, as well as an integrated vision of how they can work harmoniously together. A security baseline in a multi-cloud environment is vital due to the inherent complexity of the environment, providing a standardized security starting point across various services. Enhanced visibility is crucial in interconnected multi-cloud settings, with the security baseline offering a clear framework for effective security management across diverse platforms. The Plan, Do, Check, Act process is a great tool for creating a baseline for security policies that involves a systematic approach. The first phase of the process is the planning phase. Identify your organization's critical assets that require protection. Assess current security configurations, vulnerabilities, and risks. Establish desired security goals and define clear objectives for your baseline. Reference industry standards and best practices to inform your plan. The next phase is the implementation phase. Implement the security measures identified in the planning phase. Establish processes and guidelines to adhere to the baseline. Train staff and users on the new security policies. Ensure that security tools, software, and hardware are properly configured to align with the new baseline. The third phase represents the validations of the security measures. Collect data and analyze the success of the baseline in real-world scenarios. Monitor the effectiveness of the implemented security measures. Identify any deviations or non-compliance from the established baseline and document findings. In the last phase, it's time to act. Take corrective actions based on findings from the check phase. Adjust and refine security policies to address any gaps or issues. Continuously review and update the security baseline as threats and technologies evolve. Loop back to the plan phase to ensure continuous improvement in the security posture. We will need to define the scope for our security policies. One way to do that is by thinking in layers, derived from defense in depth as common methodology in designing security architectures. Each layer comprises protective measures against specific threats. The role of governance is to establish and enforce consistent policies, procedures, and standards across the cloud environment. Additionally, to ensure compliance with regulations and standards. The Cloud Center of Excellence has the responsibility for governance, risk, and compliance, and will also manage the development of security architecture for the cloud. GRC management has the responsibility for implementing an information security management system, an ISMS. The ISMS consists of policies, procedures, and guidelines. Some of the top layer policies will describe the Cloud Center of Excellence responsibilities for security. Policies for identity and access must ensure strict identity verification and authentication protocols. Policies must include attribute-based access controls for precise access management, ensuring the least privileged access. Additionally, procedures for maintaining and regularly updating access permissions and monitoring all access and modification activities on sensitive resources. Security operations and infrastructure include a policy and a process for a security incident response plan. Policies must include real-time monitoring and response to security incidents. Policies and processes must also ensure that an updated inventory of assets, along with the security status, is up to date. Policies for endpoint security must ensure updated, patched, and policy-compliant endpoint devices. Also include policies for antivirus, EDR solutions, and monitoring. On the application layer, add policies that include adherence to secure coding standards, periodically testing applications for vulnerabilities, and deploying security measures like web application firewalls. Policies are needed for making sure sensitive data is encrypted, data loss prevention strategies are implemented, and regular data backups are conducted. You will also need data retention and disposal policies. Ensure all policies align with each architectural layer, focusing on prevention, risk management, and compliance adherence for a secure and effective cloud environment. Each layer's policies should work harmoniously with others to provide a robust defense against unauthorized access and data breaches while meeting legal and regulatory obligations. Security policies and forthcoming principles do not stand on their own. Typically, they are defined by industry or public frameworks to which a company must adhere. There are two types of frameworks: mandatory industry frameworks and best practices. Examples of industry frameworks are the Health Insurance Portability and Accountability Act (HIPAA) for healthcare, and the Payment Card Industry (PCI) Data Security Standard for financial institutions. These frameworks were created to protect consumers by setting standards to avoid personal data, health status, or bank accounts being compromised. The cloud architect must have a deep understanding of these frameworks, since they define how systems must be designed. Next to these industry frameworks, there are some overall security standards that come from best practices. Examples of these are the standards of the International Organization of Standardization, ISO, and the US National Institute of Standards and Technology, NIST. Often used for cloud, we have the framework of the CIS. Cloud providers have adopted the CIS framework as a benchmark of their platforms as the internationally accepted standard for cybersecurity. The reason is that the CIS maps to the most important industry and overall security frameworks such as ISO, NIST, PCI, and HIPAA. The control of CIS take the principles from these frameworks into account, but it doesn't mean that implementing the CIS controls a company is automatically compliant to PCI or HIPAA. CIS controls need to be evaluated per company and sometimes per environment. Policy-driven governance is a foundational principle of cloud-native operations and Microsoft Cloud Adoption Framework. Azure Policy provides the mechanisms to enforce corporate standards and to assess compliance at scale. You can implement governance for consistency of deployments, compliance, control costs, and improve your security posture. Using Azure Compliance Dashboard, you will get an aggregated view of the overall state and remediation capabilities across public cloud providers. Azure Arc-enabled servers support Azure Policy at the Azure Resource Management layer, and also within the individual server machine using guest configuration policies. It is vital to understand the scope of Azure Policy and where it can be applied, such as at the management group, subscription, resource group, or at the individual resource level. As shown on this diagram, you can apply different sets of policies in different environments, such as HIPAA or FedRAMP, to on-premise or public cloud environments. You can apply Azure policies to your Azure Arc-enabled servers. This lets you see if they meet the configuration requirements that are important to your organization. And you can apply some policies to all of your servers, regardless of whether they are in Azure or not. Here are some things to watch out for both individual policies and policies initiatives. An initiative is a collection of more than one policy, which can be tracked as a whole. Microsoft Azure has a large number of built-in definitions that are published and updated by Microsoft. Some are resource type specific, so check the policy category on the right side in the top filter section. This applies to individual policy definitions and to policy initiative definitions. If you change the filter for all definition types to initiative, You can find a number of initiatives, each containing multiple policies. Some initiatives include just a few policies, while some others contain hundreds of policies. You can create your own company initiative based on policies and initiative built into Azure. If you select the HITRUST HIPAA initiative, you can see that it contains 610 policies. Health Information Trust Alliance, HITRUST, helps organizations from all sectors, but especially healthcare, effectively manage data, information risk, and compliance. High-trusted certification means that the organization has undergone a thorough assessment of the information security program. These policies address a subset of high-trust controls. High-trust framework provides prescriptive controls and requirements that organizations can use to prove compliance with HIPAA and other regulatory standards. Using the guest configuration category, we select the policy Windows machines should only have local accounts that are allowed. So how can you tell if a policy would apply to an Azure Arc enabled server or not? If Arc is not mentioned in the policy name, you can check the JSON of the policy definitions for the Microsoft.hybridcompute/machines resource type as shown in the illustration. If this is present, the policy is applicable to an Azure Arc enabled server. Press Assign on the top left to assign the policy. Inside the dialog for assigning the policy, you can define the scope and add a description if you need. Select the Parameters tab. Include Arc connected servers when you assign an Azure policy may be set to false by default. Depending on the policy, sometimes this parameters is not shown if only show parameters that need input or review is checked. Uncheck it to see all available parameters for the policy. Change to true to include Arc connector servers. Press Create to create the policy. The policy will now show up in your list of assigned policy in the compliance screen. In this screen, you get an overview of the compliance status for your resources belonging to the selected scope. In the list of policies, there is a compliance status along with number of resources in the scope that are compliant with the policy. In this example, the status shows non-compliant due to the fact that the Windows server and the scope have a local user account registered. Multi-cloud security monitoring is the process of collecting, analyzing, and responding to security events across multiple cloud platforms. It's a complex task, as each cloud provider has its own security tools and policies. However, it's essential to have a comprehensive security monitoring plan in place to protect your data and appliances in a multi-cloud environment. There are important design considerations for multi-cloud security monitoring. You need to have visibility into all of your cloud resources, including infrastructure, workloads, and data. You also need to be able to correlate security events from different cloud platforms to get a complete picture of your security posture. Automating your security monitoring and response capabilities as much as possible will help you to quickly identify and respond to security threats. Ensure that your security monitoring plan meets all of your compliance requirements. This may involve using cloud-native security tools and services, as well as implementing additional security controls. Identify your most critical assets, such as customer data and financial data, and focus your security monitoring efforts on those assets. Implement security controls at the cloud, application, and network layers. This will provide a layered defense against security threats. Use threat intelligence to inform your security monitoring efforts. Threat intelligence can help you identify and respond to the latest security threats. Have a plan for responding to security incidents. This plan should include steps for identifying, containing, and eradicating security incidents. A Security Operations Center is a centralized unit that deals with security issues on an organizational and technical level. Its primary responsibilities include the following. Monitoring actively watches over and analyzes the organization's networks, servers, endpoints, and databases for signs of security incidents or breaches. Monitoring also utilizes security information and event management systems to aggregate, correlate, and analyze security alerts. Incident response identifies, investigates, and resolves security incidents, minimizing their impact. It also develops and follows procedures for responding to security alerts and incidents. Vulnerability management is a function that regularly scans, identifies, and mitigates security vulnerabilities in the organization's systems to prevent exploitations by attackers. Threat hunting proactively searches for, identifies, and helps mitigate advanced threats that may not be detected through automated tools. And reporting ensures that organizations' cybersecurity policies and procedures comply with relevant laws, regulations, and standards. This function also prepares and delivers regular reports on the security status to upper management and other stakeholders. Collaboration works closely with other IT, network, and application teams to ensure that security is seamlessly integrated into all facets of the organization's technology infrastructure. It's important to collaborate with external partners, vendors, and law enforcement agencies as necessary. Continuous improvement enables you to evaluate and improve upon the effectiveness and efficiency of existing systems and processes. Makes you stay updated on the latest cybersecurity threats, technologies, and best practices to continually enhance the SOC's capabilities. Education and awareness provides cybersecurity training and awareness programs to employees and other stakeholders to foster a culture of security mindfulness and responsibility. Crisis and disaster recovery planning develops and maintains crisis management and disaster recovery plans to ensure that the organization can quickly recover from security incidents. Documentation maintains detailed records of security events, incidents, and responses to aid in future investigations and compliance audits. Tool management oversees the maintenance, tuning, and improvement of security tools and technologies used within the SOC. By performing these tasks, the SOC plays a crucial role in safeguarding an organization's information and infrastructure from cyber threats and attacks. Security Information and Event Management, SIEM, is a comprehensive solution that provides real-time analysis of security alerts generated by various hardware and software assets in an organization. It collects and aggregates log data generated throughout the organization's technology infrastructure, from host system and applications to network and security devices. After aggregation, SIEM software performs actions like event correlations, alerting, analysis, and reporting to help organizations identify, track, and respond to security incidents. Now let's break down how each component of the SIEM works and how it all plays together. The core functions of the SIEM give the user the ability to perform important tasks for the SOC. With SIEM, threat analysis helps in evaluating potential threats by analyzing aggregated data. By examining patterns and behavior in this data, the SIEM can flag suspicious activities. Correlation is one of SIEM's key functions. It connects related records to identify patterns or potential security incidents. For instance, if an employee logs in outside regular hours and then downloads vast amounts of data, SIEM can correlate these events and raise an alert. The SIEM produces alerts based on predefined criteria. For instance, if there is an unusually high number of login attempts, the SIEM can trigger an alert suggesting a possible brute force attack. Compliance. SIEM tools often have reporting features to help organizations prove they are meeting various regulatory and compliance requirements by showcasing that they monitor and manage security events. Log data is the raw data that SIEM solutions analyze. Almost every piece of hardware or software generates log data, which includes records of activities or events. This data feeds into the CM solutions for aggregation and analysis. Log data is collected from network, firewalls, and servers. Network visibility for CM consists of all connected devices in an organization. CM monitors network traffic and behavior to detect anomalies. Firewalls are security devices that control incoming and outgoing network traffic. They generate logs about allowed and blocked traffic, which are vital inputs for a CM. Servers host applications, databases, and other critical business functions. CM monitors server logs for signs of unauthorized access, malware activity, and other security threats. Users and workstations are also important to monitor. Users are people who operate within the IT environment. User behavior analytics, a function often found in advanced CM solutions, track user activities to detect any anomalous or suspicious behaviors. Workstations are end-user devices like PCs and laptops. CM solutions can monitor workstation-generated logs for signs of malware infections, unauthorized data access, and more. Log data from network, firewalls, servers, users, and workstations are sources of valuable data that feed into the CM solution. The CM then processes this data, correlating events across these sources to provide a holistic view of an organization's security posture. The aim is to detect, respond to, and mitigate security threats and incidents in real time or as quickly as possible. Security Orchestration Automation and Response, SOAR, is a technology solution that combines various security technologies into an integrated system to improve security operations, automate an incident response, and reduce the time it takes to mitigate threats. It's a key component of an organization's security operations center, and it's used to rapidly detect, investigate, and respond to cyber threats. SOAR technology is designed to enable organizations to automate and streamline security operations, from threat detection to incident response. It works by collecting data from multiple sources, such as network sensors, endpoint agents, and logs from security products, and then analyzing it to detect potential threats. When a threat is detected, SOAR can take predefined actions, such as blocking a malicious IP or escalating an incident to a human analyst for further investigation. Now, let's break down the core processes as shown in the diagram. Prioritize is to rank threats based on their potential impact on the organization. Business intel relates to the understanding of the business context of an alert. Not all alerts are equal. Some may threaten critical business processes, while others are less impactful. Risk means the evaluation of the potential damage or impact of the threat on the organization. And measure refers to the metrics or key performance indicators used to assess the severity and impact of the threat. Detect is to identify potential threat in the system. Collect refers to the continuous gathering of data and logs from various security solutions such as firewalls, CMs, intrusion detection system, etc. After collecting the data, the system needs to decide whether a particular set of data indicates a normal behavior or a potential threat. So that's the part when we make a decision. Triage is to evaluate and investigate the potential threat's validity and severity. Within this process, we need threat hunting, investigation, and human intervention. Threat hunting is a proactive security approach where experts search through networks and datasets to detect threats that might be missed by automated systems. Investigation is the process of digging deeper into alerts or potential threats to understand the full context. In cases where the automated system cannot make a definitive decision or take action, a human expert steps in to assess the situation. Respond is to take appropriate actions to neutralize confirmed threats. First out is remediation. Once a threat is confirmed, actions are taken to neutralize it. This can include isolating affected systems, blocking malicious IPs, or patching vulnerabilities. Workflow refers to the series of automated processes and steps that the SOAR system will follow in response to a detected threat. Workflows are often predefined and can be customized based on the organization's needs. The benefit of SOAR is that many of these steps can be automated, ensuring a rapid and efficient response to security incidents, minimizing manual interventions, and streamlining security operations. By understanding where your organization is within the different phases of the maturity curve, you will be able to identify the use cases, playbooks, and workflows most relevant to your security needs. This will provide a better understanding of your security roadmap, and better yet, how to reap the rewards of SOAR. Every SOC is a mix of people, processes, and technologies, but there are plenty of commonalities to inform each stage of your evolution. People factors. The human element is usually the greatest source of frustrations for security teams, largely due to the lack of talent and personnel, as well as human error. Regardless, security analysts are necessary for implementing, managing, and operating SOAR. Process factors. Automation is really about automating processes, knowing the processes that your team uses, all the way from mundane tasks to advanced investigation, is a foundational step in successfully adopting SOAR. Technology factors. The processes for threat detections are a critical starting point for SOAR implementation. The capability to ingest data from many different sources and across technologies is what informs a fast and appropriate response. At stage 1, the organization doesn't have the personnel or processes to support investigations, or the organization has very basic processes in place. Employees need assistance to quickly evaluate risk to the environment and to block and remove the risk. SOC at this stage might be described as ad hoc, security as an additional duty, distributed SOC, or managed SOC. Analysts struggle with getting through critical alerts. High, medium alerts are not being worked. To advance past this stage, you need to automate the most basic, repetitive tasks by using apps and playbooks. Stage 2, the organization realizes they need additional people and processes. It's likely that they have started to create SOC procedures and structures, just now starting deep investigations, and needs to quickly evaluate the risk to the environment and to block and remove the risk. To advance past this stage, you need to reduce tribal knowledge and automate non-analysis tasks, further standardizing and introducing consistency to your operations, and conducting more accurate root cause analysis. At stage 3, the organization has mature SOC procedures and processes, evaluates threats with triage and investigation capabilities, and has outsourced capabilities for deep forensics. The team is starting to leverage metrics for operational improvement and uses standard incident response methodologies. To advance past this stage, the SOC team must start using advanced playbooks to customize the environment. At stage 4, the organization is fully aware of what they need to do and how to do it. There is deep use of threat intelligence analysis and forensic triage of all host, network, and account compromises. The end goal of stage 4 is to use highly customized playbooks that consistently automate advanced workflows. The SOC needs a portfolio of tools to support the collection and analysis of logs across multiple cloud service providers. We will take a brief look at the multi-cloud enabled security monitoring tools present in Microsoft Azure and AWS. Microsoft Defender for Cloud is a unified security management platform that provides a comprehensive view of your security posture across workloads, networks, and applications. Defender for Cloud includes a variety of features such as security alerts, vulnerability assessments, and compliance reporting. Microsoft Sentinel is a security information and event management solution that collects and analyzes data from a variety of sources, including Azure resources, on-premise systems, and other cloud platforms. Sentinel uses machine learning and artificial intelligence to identify and respond to threats. Azure Monitor is a monitoring service that provides insights into the performance and health of your Azure resources. Azure Monitor can also be used to monitor security data, such as audit logs. Azure Application Insights is a service that provides insights into the performance and health of your web applications. Application Insights can also be used to monitor application security data, such as failed login attempts and exceptions. Amazon Web Services also offers a variety of security monitoring tools. These include the following. AWS CloudTrail is a cloud audit service that records all API calls made to AWS services. CloudTrail logs can be used to identify suspicious activity and track changes to your AWS resources. AWS CloudWatch is a monitoring service that provides insights into the performance and health of your AWS resources. CloudWatch can also be used to monitor security data, such as CloudTrail logs and security group changes. AWS Guard Duty is a threat detection service that uses machine learning to analyze your AWS account for suspicious activity. Guard Duty generates alerts when it detects potential threats, such as unauthorized access to your resources or malicious activity in your network. AWS Security Hub is a service that provides a comprehensive view of your security posture across your AWS accounts. Security Hub collects data from a variety of AWS security services, such as Guard Duty and CloudTrail, and provides insights into your security risks and recommendations for improvement. The right security monitoring tools for you will depend on your specific needs and requirements. Some factors to consider include the size and complexity of your cloud environment, your budget, and your security compliance requirements. In addition to the native security monitoring tools offered by Microsoft Azure and AWS, there are also a number of third-party security monitoring tools available. These tools can provide additional features and capabilities, such as support for multiple cloud platforms and advanced threat detection capabilities.